Our first speaker is somebody I've known for a long time. He runs what I believe now is the largest open source technology center in the world. Imad Sousou is the head of the Intel Open Source Technology Center, which is chartered with driving Linux and open source strategy and execution across Intel's platforms and technologies. He has a really large group of a lot of well-known open source developers who work in his organization, many of which I can see in the audience right now. And for the life of me, I don't know how he puts up with all these guys, but somehow he does it, and he has an incredible, talented team, and he's here to talk about the importance of Linux at Intel. So welcome, Imad. Tell you guys to play with me.
Hi, good afternoon, everyone. And it's as always, it's really good to be at another Linux Foundation conference. And one thing I really would like to thank Jim for, and not just Jim and the whole Linux Foundation crew for really changing the whole way we do Linux conferences to having these wonderful, whether it's LinuxCon, Plumbers, Collab Summit. These are really great conferences. So thank you very much, Jim, for all the work on this. So this is great. Okay, so we at Intel, we heavily invest in Linux and open source, and it's a really simple reason why we do that. Our customers heavily use Linux and open source. And we want our customers to have the best experience, using and running Linux and open source software on our platforms. So, and it's nice to see that that at least some folks have recently discovered the cloud. We've been working on the cloud along with other companies such as Red Hat and many other companies for over a decade now, whether doing features in the Linux kernel or virtualization, the Zen work, KVM, or all the way to virtual storage. So, and this is probably why you see probably this is one of the key reasons why the cloud predominantly run on Intel platforms today. And even long before then, we've been working on open source infrastructure for probably over a couple of decades now. Everything from Linux kernel, power management, things like projects like PowerTop, graphics, embedded Linux, all the way to, parallel computing and HPC and all of that stuff. And, if you hang around here long enough, you'll probably hear about some of these through our, we have about 50 people from Intel here this week in San Diego. At Plumbers Conference, we're doing roughly 16 sessions. Some of them are really interesting. If you got a chance to see Aryan's session on the 0.5 second software update, which unfortunately happened earlier today. I wanted to do an advertisement for him, but probably you should talk to Aryan and get some information. Really cool session, or the team that we had at the Kernel Summit earlier in the past couple of days. But today, what I want to talk about is something slightly different, a different topic, something that we've been working on in my team for the past few months, and that is about web technologies. And what I want to talk about in web technologies is this is not about the internet. This is about using web technologies to develop really just client-side applications. So this is using HTML, JavaScript, and CSS just to develop, just client applications. And so we've been heavily, looking at this, and we've been taking a look at what are really the key things that need to happen for that to become a real reality, where everybody can develop those applications in web technologies. And it boiled down that there are two big challenges. The first challenge was the API completeness. So APIs defined, at least standard APIs, are defined in a way that is incomplete. So it just does not cover what all the things that you need to do in order for you to be able to run a full-featured application. You can write a lot of applications, but there is no standard Bluetooth API, there's no standard camera API, and so on. And the second problem is power and performance. And it's really power and performance and memory consumption. These kind of go together. So these are the two big challenges. And I want to talk a little bit about what we are doing to solve some of these. So, the API completion challenge. This one is interesting because when we started looking at this, we thought, oh my God, we're so late. But it turned out that we were too early. There was, when we looked at the way these web APIs, whether JavaScript or CSS standards are being defined, the focus of all of these W3C standard bodies is pretty much focused on the internet and on the browser, and rightfully so. I mean, this is kind of what they've been doing for the longest time, and they've done an amazing job. So working with a bunch of other companies, we started collecting things, and and prior to that, we've done a lot of API definition. We've done a camera API, messaging API, calendar API, contacts, and to fill the gaps on all of these APIs, which we started proposing. And where things ended up now is that there is a new 3C system applications working group. So this is a group that is completely, the first group that in W3C that is really dedicated to defining application APIs that are done in JavaScript, HTML, and CSS. And this is a huge progress, especially given the tremendous amount of work that some of our engineers have done in defining those APIs, and at least have something to propose that also comes with some implementation. So this problem, at least, there seems to be enough, enough focus on it by companies, between us and Google and Mozilla and Vodafone and Telefonica. There's just a fairly large number of companies who really would like to see this happen and who are beginning to invest in that API definition and that API standardization. So this solves a really one big problem for us. Of course, it takes, as you know, it takes time for these to actually become actual standards, but as you also know, that we can start implementing these and people can start using them and really evolve, as the standards evolve. The second area is probably the stickier area, and this is, you probably have seen the Facebook announcement recently that, hey, we're dropping our HTML application, and we really are going to write our application in native, in Objective-C on the iOS. And it's really hard to blame them because the performance is not there. You just cannot, in most cases, it's really hard to write a very sophisticated application and be able to have that application use, have the right animations, the responsiveness, and essentially behave as a native application. It's just simply not there. And so that second challenge is actually much more difficult than the first one, the power, the performance, and so on. So I'll tell you what we've been doing and about this, but I also would like to, as you will see from what I'm saying, is that this problem is quite complex and it's quite vertical. You have to do it on every different variation of operating system and rendering engine, WebKit and Mozilla and so on. So it takes more work, and it does need a lot of help from whoever can help, who would like to see this happen. So we started, the first area that we started tackling is WebKit. And traditionally, I mean, we've done some work in WebKit, in terms of just the basic, enabling to make it run better on our platforms and so on. Over the past 4 or 5 months, this has accelerated quite dramatically. I mean, just the past 3 months, as you see from this chart, we've contributed something like over 500 patches to WebKit. And all of them really have to deal with solving that first problem that I've talked about. The ability to be able to, yes, we want WebKit to be a great internet rendering engine. And WebKit, as you know, is used just like on every mobile browser, plus on a couple of the most popular, PC browsers. So it was important for us that, also be able to accommodate being able to run applications. So we will continue that work, and people should start taking a look at that. And you will see, with WebKit 2 and some of the improvements that we've done, that these are beginning to really make some difference in terms of the performance and the completeness of the implementation to be able to do applications. The second area is performance. And performance is, what we quickly realized is performance filters down through the stack. It is literally from the Linux kernel all the way through graphics and all the various subsystems. The one key area that had probably the most impact is graphics. So one of the biggest problems when you try to do an HTML app is that you do not get the same fluidity. What boils down to frames per second where it counts. Where an application just feels and responds like it is a native application. So that is really the goal, is to get that fluidity, comparable or near comparable to a native application. So we ended up with the focus on the graphics rendering engines in order to do that. And the two ones that we started with are Skia and Cairo. Skia obviously is what's the underlying 2D rendering engine under Chrome OS, and so on, and Cairo in many different, different OSs and browsers and so on. So, and into these projects, we have, literally hundreds, if not thousands of, patches and code changes and so on. And we're beginning to see a dramatic change. I mean, we can, on some mobile devices, we're able to run applications at literally, 40 and 45 frames per second, very, very comparable to what you can do on, as a native application. So, but again, there is a lot of work to be done there, and we will continue investing here to do, to do this work, because that is one of the very key areas that, that impacts the end users. Because from an end user perspective, when you run an application, you're not worried about, hey, is the application done in C or is it HTML or whatever it is. You just want to have the application, responds and behaves as if it is, what you're expecting it to behave, which is the reason why Facebook, had to ditch HTML5, quite frankly, and do the application, their mobile application the way they have done that. And the final area is power. So with power management, I would say we solved this for native applications. We've been heavily, at least at Intel, we've been heavily focused on this for many years. PowerTop 2.1, which we just released a few weeks ago, has been a great help in terms of like identifying where are the bottlenecks, and it's been a great tool to really close the gaps in terms of, and be able to optimize for power management. The new version of PowerTop also extends that to the GPU, which is really great, because now you can take a look at the CPU and GPU and be able to optimize across these, for power. Well, but there's only one problem. The problem is that doesn't help in web applications. In fact, there aren't any really great or even decent tools like PowerTop that you can use for web applications. And this is one of the big challenges that we have, in terms of how we fix this. And quite honestly, we have, we still do not know exactly what is the right approach here. Hey, do we extend this? Do we do something different? And so on. So this is, this is again one of our biggest challenge that we're going to be, heavily working on. So on web technologies in general, we're doing quite a bit of work, and our objective is clear. We would like to see, we would like to have it to be what I would call it commercially viable, that applications can be written using web technologies. We think this will be great for the industry. This will be definitely great for Intel and everyone. And it is a lot of work to get there. And I mean, my belief is that we are in fact getting there. And that's really the only topic that I want to talk about today. So I think we still have, there's a lot of sessions that did not happen. These are some of the sessions that are left, for tomorrow and on Friday. So I encourage you to, to try to attend some of them. And also, as I understand, we're throwing an Intel-hosted reception, so you can get your tickets at our booth just right outside. So anyway. Thank you very much for your good listening, and hey, we'll probably see you at the next conference and next summit. Thank you very much.